Good morning, everybody. Today, we're going to keep rolling with our quadratic stuff, and we're going to talk about standard form. So, standard form might sound familiar. That's because we tested over at last unit, right? And all standard form means is that in a polynomial, is that the degrees go in order from greatest to least. But in particular, in a quadratic, this is exactly what it looked like when we factored, right? So you're going to have something like ax squared plus bx plus c, right? So not anything really new. It's the same stuff that we talked about before. But we want to talk about in particular how can this help me to graph? Because in vertex form, obviously, that's very helpful because it tells me where my vertex is. But standard form, not necessarily the case. So let's say you had something like f of x equals x squared minus 4x plus 10 or something like that, right? All of these things are still going to help us kind of to figure out where our graph is supposed to be, but it's not going to be quite as easy as it was with vertex form. So, first thing, the best thing that standard form does is it helps me to find my y-intercept. And if you remember back when we talked about y-intercepts and x-intercepts before, if we want to know a y-intercept, the easiest way to do that is just always to make x equals 0. Well, check out what happens when we are in standard form here. If we make x equals 0, this is 0 squared, this is 0 times negative 4, this is just 10. So what's really going to happen is for my y-intercept here, like where does it cross the y-axis, it's just going to kind of tell me that that's what my c term is going to give me. All right, and that's always going to pretty much work in standard form because this will cancel out with a 0. We're always just kind of left with whatever's at the end, right? So it is really nice. I know that my graph, this one, is going to cross the y-axis at 10. So that's probably the best thing about standard form, is I can find the y-intercept. Vertex form, it doesn't really help me with that. I would have to kind of, if I wanted the y-intercept, I would have to keep plotting points and just kind of plug in x is 0 and go from there. It would just be a little bit more work than it would be just to kind of see that it's the c term. So that's what standard form does well, is finds my y-intercept. But the vertex can still be found here. Okay? So yesterday we talked about axis of symmetry. And our axis of symmetry here is a little bit harder to see because we're going to do the opposite. Yesterday we found the vertex, and then the vertex told us the axis of symmetry. Today we're going to find the axis of symmetry, and that's going to tell me where the vertex is. So if I'm in standard form here, the axis of symmetry we call it negative b over 2a. All right, or I guess that would be x equals, because it's a vertical line, right? Negative b over 2a. And those coefficients are going to come from our a term, b term, and c term. And basically what's going to happen is they're going to tell me the x value of my line of symmetry. So in my example over here, right, when we say negative b, sometimes it's easier to just say the opposite of b. I know that's what my wife teaches, is just say the opposite of b. So in this case, b is negative 4. So negative b would just be positive 4. 2, and of course our a term is just 1 because there's nothing there. So 2 times 1 is 2, and 4 divided by 2 is 2. So my axis of symmetry is going to be the line x equals 2. So now you kind of have this good idea. I'll make a little picture for you here. you kind of have this good idea of what's going on with my graph. It crosses the y-axis up here at 10. And then I know the vertex is somewhere over here at x is 2. I'm sorry, the line of symmetry is somewhere over here at x is 2. There we go. So if my line of symmetry is there, I know I've said it like 3 times in this video without trying to, but if my line of symmetry is at 2, that also means that's where my vertex has to be, because that vertex is the point where we know they're the same on both sides. So that's always going to tell me my line of symmetry. So in this case, we found the line of symmetry. That's going to tell me the vertex. So I know my vertex here is going to be some x value 2, but what would the y value be? Well, there's no super easy way like there was in vertex form. I just have to plug it back into my equation to figure that out. So 2 squared minus 4 times 2 plus 10 is going to give me my y value of my vertex. So let's say 2 squared is 4. 4 minus 2, that's 4 minus 8 plus 10. 4 minus 8 is negative 4, plus 10 is 6. So my vertex is here at the point 2, 6. Now we wouldn't have been able to know that just by looking at my function, obviously, like we did in vertex form, but it wasn't too bad. We're going to do negative b over 2a, find my line of symmetry. We're going to use that as our x point. We're going to plug our x point back in for x and actually figure out what the y is. And so now what's cool is kind of if I was just graphing what this picture looks like, I know it doesn't have an a value, so it's not going to be skinny or wide. It's not flipped because it's not negative. I know the line of symmetry. In fact, I know the vertex is at 2, 6 right here. And I also know that it crosses the y-axis here at 10. So I can kind of come up with a pretty good picture of what that looks like, even without it being in vertex form and knowing what the shifts are. So that's what's really cool. Key points obviously would be my y-intercept and my vertex. And then we just kind of need to look at the a value to see if it's real skinny, if it's flipped, right? Is this a minimum or a maximum? Well, in this case, it's the smallest number it could be. That's the minimum of my graph. We did not talk about this either, but we can talk about domain and range here, right? So my domain, what kind of x values can I have in this function? Well, there's nothing really that limits my x values. And if you think about this thing, it would go on and on forever, right, in both directions. So my domain of a parabola is going to be negative infinity to infinity, right? We haven't had very many things that restricted x values. And quadratics do not restrict the x values at all. We can plug in whatever we want. So our domain is just going to be all reals or negative infinity to infinity. Our range, however, is going to be determined by our vertex, right? So this is kind of where we get into this idea of like this is a minimum value at the vertex because it opens up. So that means that my range, the smallest it's going to be is 6. And then it's going to go up forever and ever and ever and ever. So when I want to write my range, because we actually touch the point 6, we want to make it this hard bracket, right? It's the square bracket, not the parenthesis. It's a square in. So we're going to go 6 to infinity. Remember, remember we're talking about y values. So here, it's at 6, and it can go on forever, so to infinity. Infinity is always going to have a soft bracket. It always has, it always will. So our range is going to just be determined by our vertex. We're looking at the y values because it's range. Our domain is going to be at negative infinity to infinity all the time. Cool. Let's just run one of those back again and make sure that we're good to go. All right. So let's say I gave you g of x equals 2x and let's do negative 2x squared plus 5x minus 3. All right, and I want to know all that stuff. What's the y-intercept? Where's the vertex? Where's the axis of rotation? That kind of stuff, right? So let's go one at a time. Y-intercept. Y-intercept, super duper easy, right? If we plug in 0 for x, that's gone, that's gone. We just have our c term. So our y-intercept is just going to be that negative 3. Our axis of symmetry. That's not what I want to do. Our axis of symmetry, right? So remember from our steps, that's going to be negative b over 2a. So I look over here, my a is negative 2, my b is 5. So I'm going to go negative 5 over 2 times negative 2. So negative 5 divided by negative 4, we're just going to leave it 5 over 4. So my axis of symmetry, this time my vertex isn't at a super nice spot, but that's actually okay. We can roll with that, and it's not so bad. So 5/4 is going to be my axis of symmetry. X equals 5/4 because it's vertical, right? And then my vertex, here, we know the x value is 5/4, but we got to find that y value. So this part might be a little yucky. That's okay. So 2 times 5/4 squared plus 5 times 5/4 minus 3. All right, so 5 times 5 is 25, 4 times 4 is 16. So negative 2 times 25 over 16. I'll make life easy for ourselves. 5 over 1, that's going to be 25 over 4. Minus 3. Multiply this one, that's just going to be negative 25 over 8 plus 25 over 4 minus 3. And actually, common denominators aren't too bad here, right? If we just multiply both of these by 2, yeah, you guys can see me if I move over here, right? So negative 25 over 8 plus 50 over 8. 3 as eighths would be what, 24 eighths? So negative 25 plus 50 is positive 25. Minus 24 is just going to give me 1/8. So my vertex here is going to be at the point 5/4, 1/8. And then I could also go ahead and roll with domain and range, right? So I know that since this is negative, this is going down, I can tell you this is going to be my maximum value, right? The 1/8. You got to just look at that leading coefficient. Is it opening up? Then it's a minimum. If it's opening down, that's a maximum. And so in this case, my vertex is here. So my domain, we know, is all reals. Negative infinity to infinity. My range, this time that's the most it can be. So it's going to be negative infinity to 1/8. And make sure you do the hard bracket on the 1/8 because that's where we stop. All right, cool. That's pretty much it. Standard form, graphing. It's not so bad, and it does tell us some really cool stuff. So, all right, that went a little long. I'm sorry about that one. On a Friday? Come on, Odie, right? Let's get serious. You guys have a great weekend, and I will catch you on the flip side.